Hello, this is TelecomTV. My name is Martyn Warwick and we are in Arizona, in Phoenix in the United States, where we're at the ETSI NFV meeting number 8. And I'm talking with Charlie Ashton, who is Director of Business Development with WindRiver. Charlie, good to see you again. It's been a while.
It has.
Different company now.
That's right, that's right.
Okay, let's start here. What does WindRiver seek as its core? Its core focus, its core product, its core solutions, those areas that are in the NFV reference architecture as defined by this ETSI ISG.
So WindRiver delivers an NFV infrastructure software product which is called Titanium Server, which in terms of the ETSI architecture is very closely aligned with what they've defined as the NFVI layer. It incorporates a couple of other functions as well, but basically it's NFVI. And the whole rationale and the whole value behind what WindRiver delivers for this space, as opposed to some of our competitors, is that we deliver we deliver an infrastructure software platform that provides the full level of carrier-grade reliability that you need to have within infrastructure for telecom systems, because of the expectations that have been set over many, many years by telecom customers to have full 6 nines reliability at the infrastructure level.
Great. Now, you are in a strategic partnership with HP. Tell us more about WindRiver and HP will get together to deliver the next generation carrier grade platform, and how will that benefit the CSPs themselves?
Yeah, this is a very exciting partnership for us. This was just announced a couple of weeks ago at OpenStack Summit. And basically what HP announced is that they're going to take technologies from our Titanium Server platform that I talked about earlier, and they're going to incorporate their technologies into their Helion NFV software stack in order to be able to deliver full carrier grade reliability within Helion. So this really benefits telecom service providers in 3 ways. The first way is, carrier grade reliability is all about protecting the revenue stream for service providers. Sure. Because expectations have been set with the customer base, both enterprise customers and consumers, that services are basically always on, certainly at the service level, that you have 5 nines reliability. And if you're not able to deliver that as a service provider, you end up paying very significant, service level agreement penalties to your enterprise customers. And you also lose customers because of churn. So firstly, carrier grade reliability is all about protecting the top line revenue stream for the service providers. Secondly, what we're doing with HP is enabling them to develop a solution that really contributes significantly to the OpEx reductions that are a key reason why service providers are doing NFV anyway. And we really help them do OpEx reductions primarily through our accelerated virtual switching subsystem, which allows them to support many more subscribers per server or per rack than what they could support with standard open source technologies. And once you can have more subscribers per rack, then obviously that helps to improve your OpEx and to reduce your OpEx. And then thirdly, because this is a fully packaged solution that we have and that we make available to service providers along with HP, that accelerates their deployment of NFV infrastructure, which enables the service providers to gain market share through first mover advantage in the market.
Great stuff. A slightly trickier question for you now. The ETSI ISG, is it actually defining what you would regard as the necessary performance, availability and reliability requirements for the carriers to build the very best platform there is? And if not, what's WindRiver doing to help ETSI get to the point where you think that is exactly where they should be?
Well, what ETSI is getting to, and especially with the phase 2 ETSI initiative that really is the main topic of discussion here, is they're getting to the point where the overall NFV architecture is defined in enough detail that vendors like us and like HP can then start to deliver and develop solutions that will be precisely interoperable with all of the other vendors that are contributing other elements of the architecture. So that's where ETSI is getting to through both the first phase, which is really completed now, and the second phase of the work that they're doing. So WindRiver is really contributing to this, I would say probably in three major ways. First of all, we have a lot of very unique expertise and knowledge about how to deliver carrier-grade reliability in NFV, in telecom infrastructure. And so we're participating in various working groups within the ETSI ISG where we can bring that expertise to the group, and we can provide feedback and suggestions as to how the appropriate specifications should be defined so that the infrastructure for NFV can meet the reliability objectives and the reliability needs that customers have. Secondly, we have a lot of experience at WindRiver in contributing software into open source communities. And as these various open source initiatives spring up and evolve around NFV, then we'll be able to contribute code that adds a lot of value into those open source repositories. And then finally, a lot of our business is also built on taking code from the open source community and then doing everything that you have to do for that code to actually end up in a product deployed in a commercial network. So we have a lot of expertise in pulling that code down, packaging it, hardening it for carrier-grade reliabilities, integrating it with other functions, and then packaging and supporting that as a commercially supported product out to the telecom equipment manufacturers, the system integrators, and the carriers. So those are really the three ways that we contribute to the whole ETSI initiative here.
Thank you. Final question in this particular section, Charlie. There's been a lot of emphasis latterly in the back end of phase one of NFV on POCs, proofs of concept, and there are various proofs of concept underway in laboratories, in situ, in various parts of the world. But of course that is in a particularly refined environment. When you go out into field trials, which are going to be necessary before you can go to commercial deployment, and given that the first commercial deployments, people want them timetable for 2016, so a year and a half, a bit more hence. What do you think it's going to take to be able to move from that rather rarefied proof of concept environment into a real field trial?
Well, most of the proof of concepts that have been started, and in some cases have been completed so far, they've really been focused around very specific groupings of subsystems from typically 2, 3, 4 vendors. So they've been very focused on individual technical details of the ETSI architecture and really designed to prove out, the feasibility of the architecture and some of the principles that have been defined by ETSI. And I think they've been very successful in doing that. But that's a long way from having an NFV deployment, in a full commercial network. One of the very key issues that the carriers have to address before they can deploy NFV, at scale, is the whole question of having the right level of reliability in the network infrastructure. That's not really important if you're just doing a POC. When you're doing a POC, you're just trying to prove that something works technically. Yeah. But that's very difficult. That's very different from rolling out that technology, to serve millions of subscribers that have an expectation that their services will be up, 99.999% of the time. So what we see is a lot of interest from the service providers in bringing carrier-grade infrastructure platforms in to actually run the applications and the POCs that have been trialed, so that by the time they roll this out into live commercial networks, they can meet those reliability goals that are just so important.
Excellent. Charlie Ashton, thank you very much indeed.
Thank you very much.